Let's study about permutations. Permutation. A permutation is an arrangement in a definite order of number of objects taken some or all at a time. So permutation is an arrangement of things, number of things, taking some or all at a time in a definite order. It should be, that means order is important in permutation. Permutation means immediately you should recollect that's an arrangement of n different things taken some or all at a time. Let us take an example. Suppose there are three different objects are there. Let me take three distinct objects. A comma B comma C. These are the three different objects. Now taking two at a time, so the number of ways we can arrange the two things from the total three things, taking two at a time. So how many ways we can write here? First I can write AB, this is one arrangement, and AC, this is another arrangement, and I can write BC. And also we can observe that in the first arrangement AB, order is important. Here first A then B, so we can also write another one, say BA, this is different arrangement, and AC, first A then C, so let me write C first then A, this is also different arrangement, and BC, so we are getting here CB. So AB, BA, AC, CA, BC, CB. So total how many arrangements we got it here? 6. Means we can say the number of permutations. We can write here the number of permutations of three different things taken two at a time. Taken two at a time is how many? 1, 2, 3, 4, 5, 6. Answer is 6. 6 different ways. So permutation is, and it's an arrangement, and very important thing you should remember, it's an order is important. Arranging and order is important. AB and BA both are different, right? Now permutation of things means arrangement of things. This is a note point. And now let me explain one more example. Write down all the permutations of the vowels A, E, I, O, U in English alphabets, taking 3 at a time and starting with A. So here we need to write all the permutations. Write down all the permutation of the vowels in English alphabets, taking 3 at a time and starting with the letter A. This is a condition here, and there is a condition here starting with A, because from the A, E, I, O, U different ways we can write. There are many ways we can write. So among them, taking 3 at a time and starting with only A. So we want only three things. So always starts with A only. So what is it? First let me take A here. Everywhere we can write A only first. It is a fixed, that's condition. First if I write here, if I take here E and then I, and then again I can write A, I, E, and now I can go with A, E and O, and next I can write A, O, E. I'm going in an order. A, E, then E, I, and again A, E, O, and again O, E, and then A, E, U. Let me write E, U, then I can write again A, U, E, then again next. So A, what is left over here? A, E, U is done, A, U, E is done. Next I, O, A, I, O, we can write A, O, I, this is also done, and again A, OU. We can also write this AOU and AUO. This is also the way you can write. And next IU. Yes, it's not there. So we can write here AIU or AUI. So total how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So anything else which I missed? I think everything is completed. All the different arrangements which starts with A is completed. So there are total 12 permutations. So these are all the different arrangements we can say. So just remember, permutation is an arrangement of n different things taken some or all at a time. So here how many you are taking? We are taking only 3 at a time. So that too with the condition that starting with A, right? Now let us continue with next. Permutations when all the objects are distinct. Let's see the theorem. The number of permutations of n different objects taken r at a time, where 0 less than r less than or equals to n. So let's consider they are positive integers. And the objects do not repeat is n into n minus 1 into n minus 2 into and so on n minus r plus 1, which is denoted by npr, or we can write p of n comma r. That is given npr is equal to n into n minus 1 into n minus 2 into and so on n minus r plus 1, which is given as a formula n factorial upon n minus r factorial, where r is less than or equals to n. Okay, see what is given here, the number of permutations of n different objects. So just before we have seen that permutations are nothing but arrangements. Permutations means arrangements of things. So here n different objects taken r at a time, and it is given as n into n minus 1 into n minus 2 and so on n minus r plus 1. So let us prove this one. Let us consider the n different things being a1, a2, a3 and so on an. These are n different objects. So among these n different objects, we need to select some r at a time and we have to arrange them. So number of ways, or we can write number of permutations of r things out of n different things, different objects, will be same as number of ways filling up the like r places. We need only permutations of r things, right? So the number of ways of filling up the r vacant places with the given n different things, with the given n different objects. So let us take r different spaces 1, 2, 3, 4, 5, 6 and so on r minus 1 and so on r. Let me take this as box, r boxes. This is the first box, second box, third box, fourth, fifth and so on. This is r minus 1 and this is rth box. Now we have to distribute these n different objects by taking r at a time, and we have to arrange them. Like an example, suppose here we have seen before example, suppose a b c, three objects are there. Taking two at a time means we can write a b or b c or c a, or we can also write b a, or we can also write c b, or we can also write a c. The same manner here are things we need to select, r objects we have to select. So out of n things, in first place can be taken in how many ways? We'll have n chances, means either we can take a1, or we can take a2, or a3, or and so on, an means nth object. So first, to fill up the first box here, first vacant place, there are n possible chances, n ways are possible. And the same way, the second box can be filled up in, if one of the n objects are filled, taken, then the remaining will be n minus 1. Then the second box will have n minus 1 chances, and so on, continue. If two objects are taken out, then the third box will have n minus 2 possible ways, and fourth one will have n minus 3, and fifth one will have n minus 4, and so on. This r minus 1 will be n minus c. Here for second box we had n minus 1, for third we are getting n minus 2, means 1 is less, 4 means 3 are getting, 5 means 4. So n minus r minus 1 minus 1, n minus r minus 1 minus 1 we can write here, or the next box will be n minus r minus 1, means we can write here n minus, let me write here, because n minus of r minus 1, n minus r minus 1 minus 1 we can write, and similarly here n minus of r minus 1 we can write here. That is n minus r plus 1 possible ways for the last box to fill up. And now, by already we have studied about the fundamental principle of counting. By fundamental principle of counting we can write here, by fundamental principle of counting, since one after the next succession we have to write the objects here, so all are compulsory, so we use the multiplication principle. First n, then into n minus 1, into n minus 2, into n minus 3, into n minus 4, and so on, n minus r plus 1. And this is the number of ways. So by fundamental principle of counting we can say the number of ways of arranging r things among n different objects is nothing but n into n minus 1 into n minus 2 into and so on n minus r plus 1. So we can write it as, so therefore we can write this as npr, or we can also write it as n of p comma r, which is equal to n into n minus 1 into n minus 2 into and so on n minus r plus 1. Now I would like to write this in factorials. So we have completed the first one here. So the number of permutations of n different objects taken r at a time, and the objects do not repeat, there is no repetition here, is n into n minus 1 into n minus 2 and so on to n minus r plus 1. Now let us prove this formula here, that is n factorial upon n minus r factorial. For that, so let me multiply and divide with, so n into n minus 1, n minus 2 and so on n minus r plus 1. If we can decrease the numbers, the next number will be n minus r plus 1 minus 1, that is n minus r, and the next number can be taken n minus r minus 1, and so on up to 3 into 2 into 1. Just like I will give an example. Suppose we have written here 7 into 6 into 5. To make this as a 7 factorial, what is necessary? So you should multiply the next numbers, that is 5 minus 1 4, 4 minus 1 3, 3 minus 1 that is 2, 2 minus 1 1, means until the last number 1, so that we can write this as 7 factorial. Similarly up to n minus r plus 1 is there, So the next number can be subtracted by n minus r plus 1 minus 1, that is n minus r, and again next n minus r minus 1, and so on till 1 you get. So these are the terms here you multiplied. So let us divide the same here. So n minus r into n minus r minus 1 into, and so on, 3 into 2 into 1, just like here divided with 4 into 3 into 2 into 1. Just observe the example and see this, so you will understand better. So that we have, now it's a product of 1 into the numerator, if you see 1 into 2 into 3 into and so on up to n numbers, means it's a product of first n natural numbers. So we can write this as n factorial, and the denominator we can see 1 into 2 into 3 into and so on up to n minus r numbers, that is n minus r factorial, right? So just like here in the example, 1 into 2 into 3 into and so on 7, this is the numerator is a 7 factorial, and the denominator 1 into 2 into 3 into 4, that is 4 factorial. The same thing here happened. So we can write here n factorial, this is npr is equal to, we can remember it as n factorial upon n minus r factorial, means the number of permutations of n different objects taken r at a time can be given by n factorial upon n minus r factorial. Okay, now let us see some results. Result 1, the number of permutations of n different things taken all at a time is npn is equal to n factorial. Also, the number of permutations of no object at all is np0 is equal to 1. So here the permutations with arrangements of n different things taken all at a time, means how many vacant boxes here. So you need to fill up all the n boxes. Say this is n first box, say this is first box, this is second box and third box, and so on, this is the nth box. So all these n boxes must to be filled because all n objects are taken at a time, so that we may have, the first box will have n possibilities and the second box will have n minus 1 if there is no object repeating, no repetition, then third one will have n minus 2 and so on, and this will be having at last 1. So by the fundamental principle of counting we can write, so you can continue as before, like n into n minus 1 into n minus 2 into and so on, 3 into 2 into 1, so which is nothing but n factorial. It's a product of first n natural numbers is n factorial. So we can write here npn means number of permutations of n different objects taken all at a time, all means n at a time, which is equal to n factorial. Okay, and also we can reduce one from here. We can also prove that 0 factorial is 1. We can also prove 0 factorial is equal to 1. Let me explain. So we have npr is equal to n factorial upon n minus r factorial, where r is less than or equals to n, 0 less than or less than or equals to n. And if you want to select all number of permutations of n different objects taken all at a time, that is npn is equal to, we can write it as n factorial upon n minus n factorial is 0 factorial. And here we have got that npn is nothing but n factorial. So we can write n factorial is equal to n factorial upon 0 factorial. So from here cross multiplication, 0 factorial is equal to n factorial upon n factorial, which is equal to 1. So from here also we can just prove it, 0 factorial is equals to 1. And the next, the number of permutations of no object at all. So no object means we are taking among all different n objects, we are not taking any object. That means it is same as, let me write here, arranging no object at all is the same as leaving behind is same as leaving behind all the objects. Leaving behind all the objects means it indicates only one. There is only one way. So thus we can write that NP0 is equal to, means no object means zero objects taken. It's only one way, that is NP0 is equal to 1. Or also we can write this 1 can be written as n factorial upon n factorial, right? So n factorial upon n factorial is 1, and this can also be written n factorial upon n minus 0 factorial, n minus 0 factorial. So when you're just comparing in the form npr is equal to n factorial upon n minus r factorial, here r is equal to 0. So we are taking even r is equal to 0, integer 0 also we are taking. But our condition before 0 less than r less than or equals to n. But in this case we can also consider, means from here onwards we can also indicate r is lying between 0 to n. Means this formula is also applicable. NPR is equal to n factorial upon n minus r factorial is also applicable for r is equal to 0 and positive integers. 0 less than or equals to r less than or equals to n. Okay, now let us see another result. The number of permutations of n different things taken r at a time when each thing can be repeated any number of times is n to the power r. So it means, suppose with an example, let me tell you, if there are three objects A, B, C, among the three objects, or let me take four objects A, B, C, D. Among these four objects, we have to select the three objects and we have to arrange. So how do you arrange A, B, C, A, C, D, or we can add A, B, D, and so on, without repetition. This is without repetition. Suppose when the repetition is allowed, when each thing can be repeated any number of times, means each object is repeated any number of times. So to fill up the three places, the first box can be taken A, the second box also can be taken A, third box also can be taken A. Or the first box we can take it A, and the second box we can take it as a B, and the third box also we can take it B. So these possibilities will be different without repetition and with repetition. With repetition means you can take that same again. If means here there are r vacant places, first box, second box, third, fourth, fifth, and so on to this is a rth box. Let me write, this is first box, second box, third, fourth, fifth, and so on. R boxes are there, and there are n different objects. Each thing can be repeated. Means in the first box we can write among n different objects, say a1, a2, and so on an. So we had n possibilities for filling up the first box. Similarly, for the second box, again, suppose if a2 is written here, a2 is an object is entered in the first box. Again, there is a possibility of writing a2 here because repetition is allowed. So you can also write a2, means again we had how many possibilities? Again n possibilities are there, even including a2 also. For the second box we had n possibilities. Similarly for the third also we had n possibilities, and fourth also we had n possibilities, fifth also n possibilities, and so on. Rth box is also having n possibilities. So by fundamental principle of counting, we can say the number of permutations or the number of ways, the number of arrangements of n different things taken r at a time when repetition is allowed, when repetition of the object is allowed. Which is equal to n into n into n into and so on. How many times? R times, because R boxes are there to fill. So that is n to the power of R. N into n into and so on R means n power R is the answer. So we can give a result. Number of permutations of n different things taken R at a time when each thing can be repeated is n to the power of R. Okay. When there is no repetition, we will use n factorial upon n minus R factorial. When repetition is allowed, we will take n to the power R. Okay. Right.